Now we are now coming back to the point that we have to discuss about balanced three-phase voltages, that how that is generated and how that is distributed and how that functions, and why we use three-phase systems. That I have told you earlier that the first thing is that the power distribution generation are completely different dependent on three-phase. So three-phase voltages are often produced with a three-phase AC generator. So AC generator has three phases, that is known as also alternators. There is a cross-sectional view that you can see here. That is one of the cross-sectional views. So there is a stator, as you know, that doesn't rotates, but the rotor rotates. When the rotor rotates, it has a magnetic pole, north and south, and there are some phases. Each angle are 120 degree apart. A, there is a B, there is a C. Three phases. So 120 degree apart. Each angle are 120 degree apart. As we know, if we just divide 360 degree by 3, we get 120 degree. So they are 120 degree apart from each other. All 120, 120 is also 120, and each of the phases have a neutral and a phase input. As we know, uh, we can put that is a neutral A, so that is a phase A dash, and this will be a phase, first phase output. The second phase output is B, so that is B, so alternative will be B dash, and here is a C, alternative will be C dash, so that is phase output C, and that is A, B and C phase outputs, and there is a neutral on each are connected in the neutral phases. So there are four wire system but three phase output. When the rotor rotates, it creates it cuts a magnetic flux and creates electricity. That is the basic theory of electromagnetics to generate electricity. When rotor rotates from C to B dash, then the rotor will be, the axis will be this. After rotation like this, the axis will be that. After rotation, the axis will be this. So each of the section, when it cuts through, the magnetic field, the magnetic fields are rotating through the stator, and for this, when passing through this phase to that phase, this creates an electricity. Again from B, when it passes through B, this creates another electricity to B and neutral to this. Again it passes to C, it creates another electricity from C. So there are three outputs. When it passes A, B and C, there are the three phase outputs. So that is a three phase generator, and that is the basic of balanced three phase voltages. So from this we can get the three phase voltages, and if we want to just operate the appliances, we have to use the three phase system to just activate these phases to our households and industrial purposes. We can use it. Now coming back to another point, that this diagram, that is how the voltages has been generated and are 120 degree apart from each other, that I have told you before. That when you can see in this picture, this and this two phases, this A, this B dash, A dash, and C dash, not this, this, just look about it, look through to it. These three things are 120 degree apart from each other. When our rotor rotates from A dash to B dash, that means A dash means these A and A dash, they are situation at this point. So it creates a voltage from A to N, that means phase to a neutral. Now you can see a diagram like this, A from N, A N, that means this kind of voltages are known as phase voltages. Okay, VAN, VBN, VCN. Okay, phase to neutral voltages. 0 degree first voltage VAN, that travels from here to there. Second will travel from 120 degree apart. Third will travel another 120 degree apart, that means 240 degree. So that is VAN, that is VBN, that is VCN. So generated voltages are 120 degree apart from each other. Here a description has been given to you can better understand how that comes through. Here you can see three separate windings or coils with terminals A dash. There are windings or coils A dash, B dash, and C dash are physically placed 120 degree apart around the stator. Terminals A and A dash, for example, stand for one of the ends of the coils going into and the other end coming out of the page. What is out of the page and what is going into the page? Okay, let's discuss about it. Let's understand about it. Here you can see there is a C dash and there is a C. So that is a C phase, and from this we can get the C phase output with a neutral. So it is a winding, that is another winding. The both windings are opposite to each other. That means one one magnetic field will go through entering like this, the winding will entering like this, and other will just outgoing. That is entering, that will be outgoing. So there is a difference between these two, and from Lorentz law and other electromagnetic laws, Faraday's law, that will produce electricity. So equally B dash, A dash are in the same class, that will rely on the same class. So you can understand this, that how that generates 120 degree apart around the stator, and terminals A dash, for example, one ends of the coil going into another end coming on the page. As the rotor rotates, its magnetic field cuts the flux from three coils. Its magnetic field cuts the flux from three coils and induces voltage in the coils. Because the coils are placed 120 degree apart, the induced voltages in the coil are equal in magnitude but out of phase by 120 degree. So as it is divided, or as it is just placed 120 degree apart, so that induces this kind of same magnitude voltages but different phases. Since each coil can be regarded as a single phase generator by itself, each coil has been regarded as single phase, and the three phase generator can supply power to both single phase and three phase loads. Thank you very much for understanding this. I will give next lecture on how you can draw and give some notations to the circuitry.